So, yesterday we started Unit 8, and we went through and talked about binary versus ternary. Binary being any compound that only has two kinds of elements. Ternary is when you start to get into 3, 4, 5 different element symbols, all in your chemical formula. And we talked about ternary compounds requiring you to use the polyatomic ion sheet, that list of ions on the back of your periodic table that consists of covalent compounds that have an overall charge. As we go through today, we're going to take what we did yesterday. Given the ion symbols, can we make a correct neutral net zero charge formula if we cross drop and simplify? Take it up one notch today, and that is now you have to come up with the ion symbols. So I'm going to give you the compound name, and then you need to write the ion symbols down, cross drop and simplify. So let's go through some examples, and then we'll jump into Module 8, and I'll show you what I want you to do for me for Thursday. First one we're going to look at is sodium sulfide. Sodium sulfide. So sodium is in group 1, so you're going to want to have your periodic table out. Okay, so we got sodium. We said that everything in group 1, which includes sodium, is always a +1 charge. And then sulfide would be sulfur. Group 16, we said everything in group 16 has 6 valence. It's going to gain 2 and get a -2 charge. So sodium's ion symbol would be Na with a +1 charge. Sulfide is sulfur with a -2 charge. So we have our ion symbols. Now we want to cross and drop. So we're going to take the 2 from the sulfide, bring it over here. That's going to become the charge of or the number of our sodium ions that we need. And then we're going to take the 1, bring it over here. That's how many -2 sulfur. So if you think about that, 2 times +1 is going to give you +2. 1 times -2 is going to give you -2. Add those together, you get a net charge of 0. All right? Now we need to simplify this thing. Na2, we need 2 sodiums and 1 sulfur. 2-to-1 ratio can't be simplified, but we can clean up our formula. And we can make that Na2S. And like I said, I would put a box, or a circle around your final answer. So what we did there is we went from the name sodium sulfide. We found sodium in group 1, that's always a +1 ion. Sulfide, group 16, that's a -2. We took the ion symbols, we crossed and dropped, we simplified, and we cleaned it up. Let's look at calcium nitrate. All right, so nitrate. Where do we look if we have something that ends in 8 or 8? We're going to look at our polyatomic ion sheet. So nitrate is right here. Let's find it in our, there it is, nitrate, NO3 -1. So we're going to write that down. We're going to put that in parentheses and put the charge outside. Calcium, we know that's in group 2, Ca. Everything in group 2 has a +2 charge. And then we're going to cross, drop, and simplify. So we're going to bring the 1 over here. And then we're going to take the 2 from the calcium. Just like the charge is outside the parentheses, our cross and drop has to go outside the parentheses. That gives us 2 +2. 1 times +2 gives me a +2 charge. 2 times -1 gives me a -2. +2 -2 gives me a net charge of 0. So now I just need to clean this up. I can't simplify 1 to 2. So I'm going to do Ca, parentheses, NO3, parentheses, 2. And that's my final cleaned up solution. Okay? Metal name, ion symbol, group 2 plus 2. Nitrate, ATE, use your polyatomic ion sheet. Find nitrate, write down its symbol in parentheses, cross drop and simplify. All right, let's take a look at another one. Aluminum, ammonium oxide. Okay, ammonium. What did I tell you about ammonium? This is the one you're going to scour the periodic table for, and it, my friends, is right there at the top of your polyatomic ion sheet, NH4 with a +1 charge. So take NH4, put that in parentheses, +1 on the outside. Oxide, that's O, group 16. Always, always, always group 16 is -2 charge. Cross and drop. Take the 2 down here, the 1 over there. So let's take our 2 down there. Let's take our 1 over here. 2 to 1. Can't really simplify that, but we can clean that mess up. And we can rewrite that as NH4 in parentheses 2O. Block it out. Give me a circle. You're good to go. All right? And again, 2 plus 1 ammoniums balance out our single -2 oxygen. We get a net charge of 0 there. Aluminum carbonate. Aluminum, Al. That's one of our set charge metals. It's always a +3. Carbonate. Take a look at carbonate right here. Carbonate. Polyatomic ion sheet. CO2 with a -2. Put that in parentheses. CO2 -2. All right. We're going to take the 2. It becomes the subscript for the aluminum. The 3 becomes the subscript for the carbonate. Al2, CO2, 3. We can't simplify that. 2 3's give me a 6. 3 -2's give me -6. +6 -6 gives me 0. Can't simplify 2 to 3, so let's clean it up. Al2, CO2, 3 on the outside. And that's our neutral formula for that one. Okay? What about chromium IV? IV, Roman numeral. Chromium is not in group 1 or 2. It is not silver, cadmium, zinc, aluminum, or boron. It's not a set charge. So we look up chromium on the table. It is capital C, little r. IV is 4. The charge is +4 on this one. Selenide. That's selenium underneath oxygen and sulfur. So that's Se. That's going to be a -2. It has 6 valence. We're going to cross, drop, and simplify. Take your 2 over here. Take your 4 over here. 2 to 4. Can we simplify that? Absolutely. That 2 can become a 1. That 4 can become a 2. Divide them both by 2. Now we can simplify this. We can 1 4. 2 2's gives you a -4. Gives you a net charge of 0. Clean it up. Cr. Se2. And boom, you're done. Okay? CrSe2. Now, boron phosphite. Boron, group 13, that's one of our set charge. So that's B with a +3 charge all the time, every day, twice on Sunday. Phosphite is PO3 -3. How do I know that? I looked it up on my polyatomic ion sheet. Phosphite, PO3 -3. Put the PO3 in parentheses, -3 on the outside. Look, 3 to 3, equal and opposite. We don't even need to cross and drop there. +3 is going to cancel out a -3. 1 to 1, you need 1 of each. Rewrite that and clean it up. B, PO3, boom, we got her. That's it, okay? So you're going to use what we talked about yesterday. We talked about the periodic table. Everything in group 1 is a +1. Everything in group 2 is a +2. Silver, cadmium, zinc, aluminum, and boron all have set charges, right? Silver, cadmium, zinc, aluminum, and boron all have set charges. Let me zoom out here real quick. All right, let's take a look through that one more time again. Group 1, everything in group 1 is a +1 charge. 1 valence going to lose it, +1. Everything in group 2 is a +2 charge. Everything in group 17 that's to the right of the staircase they're all -1. Everything in group 16, they're all -2, -3 for group 15, -4 for carbon and silicon. You have these 5 specials, right? Silver 1, cadmium and zinc 2, aluminum and boron 3 all the time. Everything else from group 3 beyond group 2 over to the staircase has multiple charges, so they need Roman numerals. The Roman numeral is the charge of the metal. Chromium 4 plus 4 charge. If that was chromium Vi, that would be +6. Okay? Now, if you look at our module, in our module, you'll see this writing and naming ionic compounds practice. What I want you to work on today is I want you to do the first page of this. The first page of this document. There are a handful of compounds here. They are all ionic. Some of them ammonium carbonate. So those are polyatomic ions. There's a polyatomic ion here, phosphate. Aluminum chloride, so that's going to be binary. Zinc sulfide, that one's going to be binary. Use the periodic table, your polyatomic ion sheet, and come up with the ion symbols, cross, drop, simplify, and then write down your final correct net zero charge formula. And then we'll go over this together on Thursday. Okay, we'll go over this together on Thursday. If you have any questions, shoot me an email. If not, I will see you Thursday in class or on Zoom, wherever we end up